All positive and negative numbers are some value away from 0. This away idea makes sense when drawn on a number line. Here, 5 is 5 units away from 0. However, negative 5 is also 5 units away from 0. Both 5 and negative 5 equal 5 units away from 0. This value is obtained by using the absolute value operation. It's simply the number with 2 brackets on either side. The absolute value of any number is a positive amount representing its distance from 0. That is to say, it basically just makes a number positive. The absolute value of 0 is just 0, because it's no distance away from itself. The absolute value is a simple idea and a simple operation. It comes with its own properties, however, and these make great examples for how properties can reveal insights into math. The first property of absolute value is that any number is going to be made positive or 0. Negative 1 would become positive 1. 2 would stay as 2. 0 would stay as 0. Negative 2 would become positive 2. So the value is always going to be greater than or equal to 0. That can be written with the greater than and equal sign that we learned about. And now this always holds true when any number is put in here. The second property is essentially an explanation of absolute value itself. Remember, both negative 5 and 5 are 5 when taken absolute value. So any negative number is equal to the positive version of that number after the absolute value is taken. The third property comes from 2 scenarios. If you take a number, it's either going to be negative or positive. After you take the absolute value, though, it's going to be positive either way. Because the positive numbers are always greater than the negative numbers, then the result afterwards is going to be either the same or greater. This can be written as the number before is less than or equal to the number after absolute value is taken. See how these properties arise from the simple process of what absolute value does? These properties happen no matter what number is being operated on, such as negative 3. After the absolute value, that's going to be 3, which is greater than or equal to 0, our first property. The absolute value of negative 3 is equal to 3, which is equal to the absolute value of 3, our second property. And negative 3 is less than or equal to the absolute value of negative 3, which is 3, our third property. These are general rules. They emerge from the operation, but can be used to find the solutions and insights into other problems. Distance, for example, is always a positive number. If a car drives forward or backwards, its velocity might be positive or negative, but either way it moves, it's moving some distance, some real positive distance away from its center point. So the absolute value could be used here. Specifically, the first property. It's either been displaced from its original point or not. These aren't the only 3 properties that exist for absolute value. But the other properties make use of other operations properties. If you're familiar with multiplication rules of signs, then you can understand that a times b, the absolute value of that, is equal to the absolute value of a times the absolute value of b, whatever those 2 numbers are. However, if you're not familiar with that other property for multiplication, then you'll have a harder time understanding this. Properties of various operations combine and lead to more complex properties. Still, a property will hold true to any values within a range of numbers. The division property of absolute value, the absolute value of a over b, is equal to the absolute value of a over the absolute value of b, holds true for all positive and negative numbers, but doesn't hold true when b equals 0. This is an example of how a general rule may apply over a range. Learning and remembering when a general rule applies is a significant skill in math, and I hope you see that they can be easy to learn, such as when we're using absolute value as a demonstration. But as you continue to build familiarity with problems, you will improve at this skill.